Welcome again, Wildcats. So today we're looking at Friday, October 6th, graphing systems of equations on page 16. Okay, now a little note, there will be no video from Monday, October 9th because there's no school. So enjoy your Wildcat day off. All right, so if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. Now, before you get started, you're probably going to want to get a couple colored markers or crayons or colored pencils to note some of the notes in the different colors. All right, so if you want to run, grab that and come right back. All right, welcome back. I assume you ran and got something. Now let's take a look at the notes. All right, so the first thing we look at is the different forms of equations for graphing, okay? The first one is standard form, which is ax plus by equals c, where m equals negative a divided by b. And actually, I guess you could even write that slope equals m. So slope equals m, which is negative a divided by b. Where x equals c divided by a is the x-intercept, and y equals c divided by b is the y-intercept. All right, so that's standard form. All right, next one, slope-intercept form, which is y equals mx plus b, where m equals slope and b equals a y-intercept. So if you want to pause a moment to update those. All right, next one is point slope, which is y minus y1 equals m parentheses x minus x1, where x1, y1 is the point, and m equals the slope. Now, in this form, y equals a number is a horizontal line, and x equals a number is a vertical line. So if you would, pause for a moment and update point slope. I guess you could that point slope form. All right, and last, now, there's three types of systems, okay? The first one is when you have one solution. And when there's one solution, it's independent, consistent, and the lines have different slopes. And they intersect at one point, okay? 1 point. All right, the next one is when you have the same line, it's infinite many solutions, and it's dependent and consistent, okay? And the last type is when the lines are parallel, which means there's no solution, it's inconsistent, and the lines have the same slopes. So if you would, pause a moment and update your notes. All right, now let's look at our examples. Now, you might have noted that there were three types, and you might be asking yourself, why are there three examples? Okay, so be thinking about that. Why are there only three examples and three types of systems? All right, now it says graph each system and then state the solution. So to graph, we need to look at each equation. Let's look at the first one. Y equals 2 parentheses x minus 1. All right, now, so you want to be looking at your notes and see which one it matches. And it looks like its slope-intercept form is the closest, which is y equals mx plus b, okay? So we're going to distribute and put this in y equals mx plus b. So if we distribute the 2, we get y equals 2x minus 2, okay? So now this is in slope-intercept form. Okay, this is in slope-intercept form. Okay, so now we can graph it. Okay, so we start at -2. Okay, and slope is rise over 1, so we're going to make this a fraction. Okay, so 2 divided by 1. So it rises 2, goes to the right 1. Okay, and we can do that because 2 divided by 1 is still 2, but we put the divided by 1 so we have the rise over run. Okay, so from here we go up 2 to the right 1, 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 up 2 to the right 1. And then you go in the other direction, down 2 to the left 1, down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. Okay, so there's your first line. Now, let's look at the next one. So x, I'm going to put a 1. 1x, 1x minus 2y equals a negative 8. And looking at our notes, this looks like this is standard form because we have ax plus by equals c. Okay? So this is standard form. Okay? So standard form, we know we can graph with the x and y intercept. Okay? But we need to know what a, b, and c are. So 1 is a, 2 is b, and negative 2 is b, and negative 8 is c. So now we know that, we can find the x-intercept. All right, so the x-intercept we know is x, I'm using notes, x equals c divided by 8. So c is negative 8, and a is 1. So negative 8 divided by 1 is negative 8. So our x-intercept is negative 8, comma 0. So we can plot that point. So negative 1, 2, 3, 4, 5, 6, 7, 8, negative 8, 0. Okay, now we can graph the y-intercept. Okay, so the y-intercept is y equals c divided by b. So that's negative 8 divided by negative 2. So negative 8 divided by negative 2 is 4. So our y-intercept is 0, comma 4. So 1, 2, 3, 4. And we don't need to find slope because 2 points make a line. Now it looks like we're looking at the one solution because it intersects at one point. So we have one solution, which that one solution is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So 4, comma 6. All right, so that's example 1. So let me let you pause for a moment and you finish up example 1. All right, now let's look at example 2. Sorry to get some adjustments here so you can see this clearly. All right, so let's look at the first equation. So we have y equals negative 3x plus 2. Now we can see here that that's in slope-intercept form because we have y equals mx plus b. So that's slope-intercept. All right, but remember slope is always a fraction, so we're going to divide that by 1. So to graph this, we start at 0, 2, and then we go down 1, 2, 3 to the right 1. 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 And then we go the opposite direction. Up 1, 2, 3 to the left 1. Up 1, 2, 3 to the left 1. Now we have our line. All right. Now the next, we see here that it's probably a good idea to put in standard form because we're very close to having ax plus by equals c. The only thing we have to do, though, is add 20 to both sides first. That cancels, and so now you have 6x plus 2y. That plus sounds a little messy looking. Let me fix that. Plus 2y equals 20. So now we have standard form. All right, so standard form, we know we can graph using the x-intercept and y-intercept, okay? So we know that this is A, this is B, and this is C. So the x-intercept can be found, which is x equals C, which is 20, divided by A, which is 6. Now, at this point, you're probably looking, well, 20 divided by 6 doesn't look like a good point, okay? So let's move on to the y-intercept. Now, the y-intercept can be found using y equals C, which is 20, divided by 2, which is B. So our y-intercept is 10. Now, that's a good point for us, okay? So we like 0, 10. Okay? So 0, 10, that's that point right here. So we need another point. Well, that's where this is important. We know that slope is negative A divided by B. Okay? So we're not going to use the x-intercept. Okay? Let's use slope. So slope equals m, which equals negative A, so negative 6 divided by B, which is 2. So our slope is negative 3. This reduces to negative 3 divided by 1. Okay? So now from our y-intercept, we go down 1, 2, 3 to the right 1, 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 down 1, 2, 3 to the right 1. All right, and you'll notice that these two lines are parallel. So when it's parallel, we know it's no solution. Okay, so pause for a moment and update example 2. Now this video is going longer than normal, but I really think it's probably best to go over all the examples in a video. Now understand, I'll go over all, one, or none as y'all request in class tomorrow. Okay, so just keep that in mind. Okay, if need be, I'll go over any of these examples again. Like I said, any of them, all of them, or none of them. Okay, just let me know on Friday. All right, so let's look at example 3. All right, so the first thing, let's look at the first equation. So we have y plus 1 equals 2 divided by 3, x minus 3. Now looking at that, it's probably a good idea to do slope-intercept form because it's probably going to be easy to get into y equals, okay? Actually, no. Whoa, I just noticed this is cool. We can actually use point slope because we have y minus y1, we have slope, and we have x1. Whoa. So with that said, then we know that our point, this is y1, this is x1, so this is actually point slope form. which also known, you can just say point slope. Now be careful though, because in the notes, notice it says y minus y1. That means that this is y minus a negative 1. So y1 is actually negative 1. So your point is 3, negative 1. Okay. Now we know our slope is 2/3. So with a point and slope, you can graph your line. Okay. So we graph 3, negative 1. So to the right, 1, 2, 3, down negative 1. And then our slope is up 2 to the right 3, up 2 to the right 3. And then we go down 2 to the left 3, down 2 to the left 3, down 2 to the 3. All right, so now let's look at the next line, which we have y equals 2/3 x minus 3, which is in slope-intercept form. All right, so when it's in slope-intercept form, we know our y-intercept is 0, negative 3, and our slope is up 2 to the right 3, up 2 to the right 3, up 2 to the right 3. So we see that these are the same line, and when they are the same line, they're infinite many solutions. Which we can just say infinite solutions. All right, so I'm hoping you've seen that the reason there are 3 examples is because now your examples show the three scenarios, okay? We have one solution, no solution, and infinite solution, okay? So with that, at this point, you have options. You can stop here after the video and be ready for class tomorrow and write some notes down which examples you want me to go over, or you can start working on the assignment if you like, okay? So with that, have a wonderful Wildcat day.